Our third pillar of object-oriented programming is known as polymorphism. The term polymorphism essentially means many states or many forms. And to get an idea of how that functions within our programming environment for the applications that we create, we'll continue to look at the animal class and the dog class. So in this example, we have our animal class that we have been working on that has specific attributes. So we have some member variables, and we also have some functionality built into it, such as properties that allow us to encapsulate our age and our color, and then a couple of methods such as move and make noise. Within our dog class, we currently don't have any implementation of methods or other properties in here, but we are inheriting from the animal class through this context. And that means that the dog class basically takes on all properties of that animal class. But polymorphism allows us to make changes to our subclasses which allow them to provide additional functionality or additional member variables. So as an example, in our dog class, we know that if we create a dog class, chances are we're going to have some additional properties. And one of those might be a name for the dog itself. So we can create a new variable called string name. And again, if we want to keep with all of our encapsulation, we could set that to private and create properties. But just in the interest of time and to make it simple, we'll just declare this as public for the time being. So public string name. We also might want to take a look at setting up a few other variables. So let's go ahead and create one called public string owner so that we'll know who actually owns the dog. And also what we can take a look at now is how does a dog differ from other animals in terms of its behavior patterns or what it specifically does. If we go back and look at our animal class, we see that two methods we created here were called move and make noise. And make noise has no implementation in it here currently. To give you an example of how that would actually function for polymorphism and changing the behavior, let's go ahead and do a console.writeLine statement here and just simply put in text that says made noise so that, when we call this particular method on the animal class, make noise would simply call made noise. That's what we would output to the screen. And the move method actually says moved. What we can do in terms of creating this polymorphism behavior within our classes is we have the ability to create these methods as virtual methods. And what that basically means is that they can be overridden in our subclasses. So because they're a virtual method, they virtually exist in the animal and they virtually exist in the dog, but we have the ability to create different behaviors within our subclasses. So if we come back into the dog class and then let's say we want to override that move method, then we can say public override void. And you'll see that IntelliSense automatically pops up the two methods that it knows that are virtual within the animal class. And we're going to make changes to the move. By default, when we accept the IntelliSense, it simply calls the base.move. And what that means is that if we were to call dog.move in our program, it would actually call the animal.move. But that's not what we want. So we're dealing with change. We're dealing with polymorphism here. And instead, what we're going to do is be very simple in this and say that we want to do a console.writeLine. And what we're going to do is simply output that the dog is running. And that's all we're doing for the change. We have the ability to overload this method and create multiple move methods. We could accept parameters for, if the dog is happy, the dog would be running. If the dog is sad, maybe he's crawling or whatever the case may be. So you can implement that functionality if you want to. And then what we'll do here is rather than override our make noise, we'll leave the make noise as it is, just as an example to show you what happens when we call methods that are virtual but not overridden. So we've added a name and an owner to the dog. We've changed the move method. We've overridden it. And so we'll say running when we call move. Let's go into our main program here and create a new dog. Dog spot equals new dog. And then we'll say spot dot. As you can see, we have age color that exists from our animal class. So dog.age equals, let's say the dog is 5 years old. And then spot dot, let's call the move method first. So we'll call spot.move, and then we will call spot dot, and we can say make noise. So that will actually run those two methods, and we'll not worry about putting out the age method at this particular point in time. So let's do a control F5, see what happens when we execute this. So we said running and made noise, which was essentially move and make noise. And if we come in and take a look at the animal class, made noise, we didn't override this, so it called this method. And in Doug, we simply said overridden the move and we called it running. So that's what got output instead of moved. So that's just a quick example of polymorphism. There's a lot more to it. As you get into C# and you get into object-oriented programming, you'll gain an understanding and a deeper appreciation for how polymorphism allows you to really work with your classes, work with your hierarchy to set up this whole inheritance hierarchy of classes, and then the ability to morph and make changes to those classes as you use them in your programs. We're focusing on C# here, not specifically object-oriented programming concepts, but this is an example to show you how C# fully implements that object-oriented programming functionality. We've taken a look at the inheritance, we've taken a look at encapsulation, and then this demonstrates the ability to implement polymorphism in your C# applications as well.